Hello everyone, this is a simple video I am making to introduce you to computer graphics. Most of the video will be shown as a demonstration on the screen directly. But before that, this is just a briefing. What you are seeing also right now on any device is also computer graphic. The video also is graphic. But graphic comes in different shapes, different types. It is seen differently and internally also stored differently, based on which there are various types, various software. So we are going to discuss a good amount of that in today's video, mostly in the form of just demonstration. I'm not going to show you any particular techniques, but it will just be simple demo of different types of computer graphics. Let us start the actual presentation. Is the entire screen of my computer. You are seeing my face. I have taken it just for continuation of the previous video, but now it is not moving. This is a screenshot I have taken from the previous video itself. Now this is taken for the purpose that I want to demonstrate that everything on the screen is consisting only of dots. Let me try to zoom in on this image. Now you can see it as dots. I will move it around. So everything that you see consists of dots. This is true for everything that you see on almost every device currently, including printers. Everything or every picture or whatever you see is made up of dots only. Let me look at another image. This is a photo that I have taken, and I am showing you because it's an interesting photo. Let me zoom in on that also. Wait. So by some mistake I have drawn something on that flower. So if I zoom in on that, here also I can see dots. So this is a proof that everything in computer consists of dots. Actually everything that you see on computer consists of dots. That should be corrected that way, because internally it could be something different, and that is what we are going to discuss in this small video. So is it that all devices make the picture by dots? It's not 100% true. Previously there was at least one device. I might superimpose a photo of that, or you can look it up in Google, which was called as a pen plotter. Pen plotter was not a device that made pictures out of dots. It actually used pen and drew it like a line. Similar way that pen plotters have become obsolete today, but today you have what is called as stencil cutter. So they make they cut plastic and make stickers. So that is not exactly made of dots. That is only two devices that I know are not creating the picture by dots. Now what can you do in this picture with dots? You can do some selection, like I have selected this. I am copying this now. After I copy it, I can paste it somewhere else. Sorry. I can copy it, then I can paste it, and then I can move it somewhere else. See here. So I have copied some portion, pasted some portion. There was some mistake in doing that, but this is what essentially you can do with a picture or a photo that consists of dots. I can make it smaller in size. If I just want the flower, I can just crop only that much. Now I'm taking this image, selecting only this portion, and I am cropping it to that selection. So I have only this much image left. So this is what the basic things that you can do, and then you can do superimposition and something like that with a picture that consists of only dots. I'll pause here. What I specifically said was that whatever you see on the screen is all made of dots. This I stressed because what you see and what is stored internally could be different. Now, these dots are technically called as raster graphics, and internally each dot is stored as some amount of data. I will not say what that is because that differs from format to format. Now, since each dot is stored separately, it requires a lot of space for a large image or a photo. This is where the other type of graphics comes into picture. The other type of graphics is called as a vector graphics. Instead of storing the appearance of the picture as dots, it stores it as geometry, which means if you have a circle, it will store internally as the center point of the circle, radius of the circle, that's it. And then the software draws it every time when you want to see it. When you zoom in, it makes it more and more clear. So the vector graphics requires much less storage space and it shows much more clarity, which I will demonstrate on a screen demonstration after this. What a vector graphics is and what a raster graphics is. Let's directly jump to demonstrating vector graphics. I'm using a different software. This is a blank page. All that pattern that you see is just to indicate that it's blank and not a white filled object. First thing I'll do is I directly go and draw a rectangle. See, this is a white rectangle with a white fill and a black border. Now I can change any of that. I select this object, change the color of the fill to red. I select it and change the stroke width to thicker. Let me make it more thick. Then I can change the stroke color to something else. I can copy this object and paste it, and paste one more times, and I'll change the color of the fill in both these. Now you can see that I have three different objects, distinct objects, which I can move here and there, and which I can also bring on top or completely take behind. So this is what is vector graphics. Oh, and more important is I'll show you zooming. For that, rather than a rectangle, let me draw a circle. I've changed the stroke color. Okay, now I am zooming in on this picture, and see, I keep zooming and it never gets pixelated. I can do that almost as much as I want. There could be some limitations with the software. Now to demonstrate the same thing and compare, I'll use another illustration, which was given as a sample with a software called as GoScript about 30 years ago, or slightly more maybe. That's why this has a classic value. It was drawn by someone. And if I zoom in on this raster image, this I've opened a raster image of that same software, same picture in a different software. It's not very high resolution. If I zoom in on that one, you can see here the pixels already, and then there's a background. I'll zoom out and I can see the whole picture. Now if I see the same thing in the other software, now the earlier raster image was occupying about 132 KB space, and this is only about 69 KB in SVG format. If I zoom in on this one, this is the original created illustration in using what is called as a PostScript. It has been I converted it to the raster. Now see here, this version I have downloaded recently from some website which had a SVG version of it. Don't bother about what these file formats are, we may discuss it in some other video. But see here, you can see the clarity. Now here, are there any objects or are there any particular objects to be filled? Yes. Suppose if I select this, just a hair of the it's not hair, it's I don't get the word, it's whisker, sorry, it's the whisker, and I can apply a different color to it. I make it yellow, so the whisker has become yellow. I can select the tongue and make it green. Okay, because of some shading, the tongue is in two pieces. I can make the teeth, instead of yellow I can make it white, slightly white it has become. So this entire illustration consists of multiple objects which are of different fill and shade, and it is entirely a vector graphics. I think this demonstration is sufficient. If you go in deep, there are several advantages, disadvantages, and so many different things that you can do with vector graphics as well as raster graphics, which is not the topic of this video. But the topic of this video and the intention was to just let you know that there are two clearly different types of graphics. And this is the fundamental thing that anyone doing anything with graphics needs to know. Beyond that, there is CAD, there is GIS, then there is 3D modeling, 3D graphics. There's so much in computer graphics which comes beyond this point, but this is the starting point.